we will cut over to the discussion of time, and it's and Lawrence will join us. The discussion of time and how it is used on Dragonchain, and what our philosophical viewpoint is on it, right? So this was from a presentation that I gave months ago, sometime, I think it was earlier this year, might have been late last year, either way. And it was really interesting to me because it was very focused on the way that we modeled time and scarcity in side of Dragonchain. So it starts off with, okay, traditional software. So this is in the 90s. Mark Andreessen, visionary, in NCSA Mosaic and Netscape and everything else, and extremely successful in investment, right? So he had said software is eating the world, and he meant by that all of the industries, whether you're talking about real estate, whether you're talking about retail, whether you're talking about any example you can think of, that the application of software destroys all the competition. So it's a matter of, okay, who's going to apply software to that vertical first and best. And some examples, streaming video killed the video store. Well, I guess mailed video first, and then streaming video killed. But it's all software. It was all.
Well, what it did was open the door for things like Netflix to say, you know what, we can stream this, and crazy fees, we can get around that for you. Mm-hmm. Airbnb didn't kill the hotels; it was unavailability of them, and so the software found a way in, and that's kind of what you've done with time.
Yes, and that's the driver, though. So it was the amount of, and this is something that early on in Disney, that in these software companies, you still had to have an alignment of the stars. You still had to have everything perfect. You had to have the right leader. You had to have the right message. You had the right timing, and have enough money to do it. And that's really rare. But then you get the Amazons, you get the Ubers, you get the Googles, you get things happening. But it was very hard to control, and what blockchain did. So, in my opinion, this is the basis for the value in blockchain. It obviously you would have it prevents double spend of virtual assets. That's a good thing. But before you get that, you have the issue of time. So, before blockchain, traditional world, you could have a picture of someone holding up the moon landing, New York Times, and know that picture came after the event.
Right.
And it's measurable, and it's like, how much would it cost to fake the front page before that, right? So it's an interesting thing. But the issue is there was no way with that mechanism to put an end date on that picture. That you can't say this picture didn't happen just last week, because they could have taken a really old newspaper and held it up last week.
Around it.
There's no way to frame the other end of it. So with blockchain, what this and the assembly in blocks and the application of some measurable proof, which is a proof of work in Bitcoin, that you could actually put a start date and an end date on that block, and you can say any of the transactions that happen in there I can prove happened between those 2 points in time. Even if the time is somewhat imperfect, if you're not using NTP or whatever else, you don't even have to trust that so much. You just know the sequences of this, and I know that the sequence was at least this long ago. And what that gives you is the fact that you have an assembly of transactions, and you can have whatever algorithm you want. You can say, if any of them conflict, I'm not taking either, or I take the first I see, or I take the biggest, or whatever you want, or I take the one that paid the most fees, right? And you have a deterministic way to handle the transfers, right? So that's where you then get the double spend protection, and double spend protection then is where you get probably what is at least most interesting, and it's not perfectly refined yet because exchanges are so inefficient, because governments still have not made it easy to do what they could do, right? So if it was in my opinion, although it would be ugly and you would have a lot of negative things happen, in the end, you have a lot more value because the exchanges would be a little more, there'd be more liquidity, there would be more ease of use for normal people. But one way or another, the important point is that this technology has allowed, it's kind of the next step where we've taken software and we're adding an actual, real, intrinsic value or marketplace capability inside of software itself. So a software can now define its own value and its own market in ways that then drive humans to do things, right?
It's a metric of value exchange, and it incentivizes people to
Right.
do or not do something.
Or not do things, yep. That,
Which-
and good or bad,
Well, which
It's-
is how
yes.
you're preventing 51% attacks.
yes. And this is the crazy thing about blockchain, that it has these marketplace capabilities, and I tend to think that the fastest path from any point A to any point B is market driven. That I think it's I tend to think that it's better than machine learning. It's more efficient potentially than machine learning, depending. But and not that machine learning shouldn't be used at all, but it's just that it is such a crazy and demonstrable value. You can get a lot of information out of people if there's an incentive for them to provide it. So lots of neat things there. And one of the main points is, Satoshi did not travel the world to convince people to use Bitcoin. He hid himself. He did everything that should probably kill a project, right? It was controversial. He was a hidden figure that the press would make out to be
couldn't
very
trace it to one
shadowy.
person.
Lots of things. And there's been, of course, tremendous amounts of drama in the industry, and yet somehow it's still the largest computing concern on Earth. Why is that? It's proof in the pudding. It really is what I'm saying, that it really does drive that, and I would like to expand that further rather than just Bitcoin and just Ethereum. It'd be nice to really push that further. So that's all of that. And we should go next into how we talked a little bit about time in one of the AMAs earlier, but when we first formalized what was at the time called DDS, as Dragon Days of Slumber, a measure of how many dragons for how many days that they've not moved. Right, they're in slumber. They're basically sitting there, and we the first pass was that we actually used was for entry for beta program. Easy enrollment. That you didn't have to fill out a form to enter a beta program, that you just had to have enough time, and we were able to say limit how the max number of entries based upon the blockchain itself. We could see how many people have how much time. It's like, okay, we want no more than 1,000 people, so we set the time here and we're good.
So what's the fundamental difference between Dragon tokens and time?
Time is entirely a score derived from tokens. It's not a token itself. In fact, that was a huge legal concern. We had some nefarious characters attacking us early on, saying they can't do this. This is a violation or whatever. And we're like, well, we went to our lawyers and said, is this a problem? It's totally a score. There's no token here. You can't even transfer it, right? And that was some of the economic point of it, is that it's hard to acquire. It isn't something you can just go to the store or go to the marketplace
To
and
an
buy.
exchange.
You had to do something else and wait, right? So it was a beautiful thing because you can't manipulate time, at least most people. And so and the lawyers, they were like, yeah, it's a score. There's nothing about that.
It's an attribute of how long you've held your Dragon tokens.
Mm-hmm.
You can calculate it very easily,
Yep.
but you can't acquire it except by hodling it.
Yep.
And if you don't have it. So why did you build time into the system?
This is actually really good info. It's usually hard to describe, but the primary purpose was it was interesting. It was a unique attribute we could add.
Right.
Second, we knew we could use it for betas. Third, we knew that we could use it for dragon scale. That is, here's how to basically control the curve of who can do what when, and to incentivize people to act well. And part of that acting well was both for the protection of the people themselves, that we wanted to incentivize good operational security. So we wanted to basically incentivize people to not hold their tokens in an exchange, right? And there are multiple reasons. For one thing, it'll help with volatility, because people, if they have a token in exchange, are more likely to trade. And more so, though, for security, because so many exchanges, especially back then, had failed through accident or on purpose or who knows what. And that was the big thing, that a lot of people that were thinking traditionally would leave their stuff on the exchange. They just didn't think twice. It was like, oh, it's just like I have a Schwab account and the stocks are up there. I don't have the certificates in my safe. But we wanted to really push the fact that crypto's different. You should be owning it. You know, you don't own the Bitcoin if you don't own the keys, right? And so this incentivizes people holding it in their own controlled wallet and with their own keys, because even though you might have Bitcoin that's sitting in an exchange somewhere, you can't actually leverage because you don't have the keys to that address. So even though you say, oh, that's my address, you can't prove it's your address, so it's not your address. And so that pulled people. So it was good for volatility, it was for better security. Those were a lot of the drivers. And we were working on DragonNet a bit later, and we ended up needing a solution because we had, well, there are a couple of angles on it. We had originally intended to do and we ran a beta in early access on this, where your selection criteria was scaled based upon your time, which was good in some ways, but in other ways it was really hard. The curve was so hard to tune and not be unfair, because you would have people that would get 1 in a million selections, so why they wouldn't even want to be involved. And we also had, it was a lot less efficient to set up just the implementation, because weighted time, it was, the scales were crazy, the whales versus the small, because it was more than just the tokens, it's time itself.
Right, so good example. So if you've got a whale who can afford to buy 1 million dragons, and they hold them for a day, how much time do they have?
1 million time.
They've got 1 million time. So if the price, whatever, just picking an arbitrary number, making it $1 simple, is if you can afford to invest $1 million, you have 1 million time the next day, 2 million the day after that, and so on.
Yep.
If you have a more modest amount to invest, that 1,000 dragons that you might buy, and you hold it for 1,000 days, you still have 1 million time, but it takes more resources to hold them, so that if you're trying to leverage that, so explain how they're used in the layer structure to do transactions, because that's the beauty of it.
Right, and that's where we came, and it was basically a key. I was driving into the office one day, and it came to me that if we flipped it on its head, and instead of weighting the selection, we just said it's a purely random selection. But, and let's, let me, I'll pull up a graphic on, sorry, don't worry about that. I'm going to just show this, right? I'll pull up the graphic on.
This is a good one, yeah.
To kind of demonstrate how that ends up. Okay, so you can see that. So we are basically talking about. Sorry, I'll get to here. The drawing. Oh, this is fun, right? You get to see all the deck again. Okay, so this is the slide I wanted to show you. So if you consider one of these vertical paths, so I have a block, we take it from both sides, whether I'm a verification interested, so I'm running a verification node at level 2, level 3, level 4, versus a business. All right. So on DragonNet, unlike other blockchains, other blockchains typically have hardware as a scarcity. A node itself, on Bitcoin is pretty expensive. If you're going to compete on Bitcoin, you have to have some serious gear, and you have to have up-to-date gear. And otherwise, you're just burning energy and not actually profiting. The margins must be, I don't know, they have to be pretty slim.
We're running into a halving event, so.
Yeah, and if you're running on Ethereum, it's somewhat the same, but it's still, you have to add hardware, whether it's GPU. I'm not up on mining, so I don't even know if you can mine Ethereum with GPU efficiently or not anymore. I don't know. But either way, all of that comes to bear, and it means that the cycles when you have adoption or when you have a lot of network traffic are slower to recover, potentially upsetting for businesses or anyone seriously using blockchain. In the ICO days when token sale would go on, it would kill Ethereum for the some duration of that sale. However, on Dragonchain, we use time. So a lot of our nodes are deployed to cloud. Some of them are on-prem, but what that means is they can scale, and they can scale like crazy. So when we first started looking at it, it was interesting because we had to be very careful about the economy, since they were a lot of them are cloud-based. Because theoretically, I could be running a level 3 node, and I'm charging a penny for every block that I do. You come in and you say, I'm going to run a level 3 node, and I could scale, and since you have a node that's running on a cloud, let's say you could take 80% of the network because it can scale up like crazy. And if you just charge 99.5 cents, then you're going to get all the traffic, right? So it becomes a race to the bottom where we're both chasing each other down until one of us says, okay, I can't afford to do that anymore, and give up. And nobody's profitable, so you don't have the two of us wanting to run nodes. Instead, you have one person running a node and begrudgingly, because they're barely making any money. So what we did is we said, okay, let's have scarcity as time, random selection for a given node, for a level 3 node. I get the selection, but my node, my level 3 node, has let's say 10,000 time applied to it. Let's say we have a bunch of level 2 nodes that have 0 time applied. Let's say that happens. We have 0 time applied to level 5. And Lawrence is running a level 4, and he has 90,000 time applied. So whatever the fees were for that block to be verified coming from that business, Lawrence will get 90% of those fees, and I will get 10% of those fees. And I'm randomly selected, so depending on how many level 3 nodes there are, let's say there are 100 level 3, I don't know the current, let's say there are only 8 level 4s, that means Lawrence is going to get chosen a lot more often, so he's incentivized to put as much time as he can on the level 4. And it's all fair, because I'm building my time as I can, applying it to my level 3 node. I might be applying it elsewhere too. I might be running a business node. I might be doing something else with my time, leasing it or something. So it's extremely interesting because for us it's fair, and there's no race to the bottom situation. In fact, time saved is time earned. It's like it's really hard to get, so you're less likely to get rid of it or to lose it. And there's some interesting applications with Dragonscale for that. But then we flip that around. We talk about that same economy from the perspective of a business. And the interesting part there is, first of all, for the scaling itself, that unlike other networks, if you have a killer app come into the mix, we have multiple levels of abstraction that protect us. That is, it's on its own chain, so I don't have to worry about anything in competition there. But even with the verification network, because all of those nodes are focused on time, they scale. And so theoretically, you could have orders of magnitude increase in traffic and the same infrastructure can handle it. They'll all be more profitable, right? So you will draw more people to come in and share in that profit, but they'll take up the traffic without falling over. So that's a beautiful thing. And as for the fees, the way that Dragon Net handles fees is they're time-based, so, and they're deterministic. So if I have a business node, and let's say I know that I'm going to average around 10,000 transactions on my current infrastructure. So, or let's say I'm going to do 500 transactions this month. You know, it's a very high value transaction. Not going to happen very often. I can apply zero time, and they're 50 cents a transaction. Who cares? It's like a couple hundred transactions at 50 cents. I'll do it. Doesn't matter. Now I'm going to add in some services, and I realize, oh shoot, this is going to be 250,000 transactions every month. Now I realize I need to apply time to get those fees down. So I'm going to get them down to 1/4 cent or
And at
whatever.
some point we should put out the chart that shows the fees.
I can do that. I can do that.
You
And
need to break your chain of thought.
no, that's great. Oh boy, I probably should. I don't know if I'll be able to.
We can always do this later and put it out. In
I think
the
I can do
chat.
it from here.
Okay.
Shouldn't show that, but whatever. So we'll go in here and we'll on my test chain, right? Oh shoot, I don't have the
Primary wallet.
credentials. Darn it, I don't have credentials on this box, so we'll share it at some point. That one way or another, you have a scale, so you can apply more time and get lower fees, and they break down all the way from 50 cents if you apply no time at all to I think 1/100 cent if you apply 1 billion times, right?
Apply a
Which
lot
is
of time.
pretty rare. That's there's not that much time in the world, so. The reason that matters is the business can have a deterministic fee structure. They don't. It's more like a traditional system. They don't have to worry about the volatility, price of Dragon. They don't have to worry about the network traffic on Dragonchain itself. They don't have to worry about any of the things they would normally have to consider when they deploy a blockchain system. And it's really pretty.
The
amazing.
cost of running a transaction for, just a really simple use case of in an ERP system, back in the day when it was all paper, it cost, and I was part of a study that did this, $28 to change someone's address because
Wow.
a live human had to go and do it. And then when we built ERP systems, it went down to about $2.80. Now it's probably a rounding error of that. And what you've done is put predictability into the cost of doing transactions by being able to apply time.
Right, and it's really interesting, and both time for the purpose of network security and scaling, because there are interesting aspects on
Right.
51% attacks. That we have multiple abstractions to protect against that. Time being one, because you can see an attack coming.
Yep.
And yes, they can accelerate it if they put enough money into it, but it's much the same thing then that you have with Bitcoin, where an attack is not profitable typically because you're going to have to buy enough equipment that would be worthless if you destroy the network. That normal things, and on top of the fact that you have separation again, because you would theoretically have to attack 51% of the time on probably every one of the levels, or
On
at
each
least
of the
some.
nodes that
So
each node and each level that you're doing that, so it becomes extraordinarily expensive. So if you're doing that and you're applying that much compute power to break into someone's bank account, unless they've got a really big bank account, probably not worth it, and you'd never do it. To steal the plans for a nuclear submarine, maybe, but then we don't store any business data on the chain, so there's
You
other
have-
ways to secure
you have
it.
the traditional DevOps.
Yeah.
And honeypots and everything else you would have, right?
That's
So it's actually beautiful. So that's some of the magic behind time, and there are more. I would call them. Let's see, what's the right word? Not esoteric, maybe exotic uses as well. Dragon Scale. There's a draft white paper out on Dragon Scale, and it has some really crazy advanced uses for time, which is a way to demonstrate signal with scarcity, but without value transfer, right? It's interesting because we call it devotion, and that's it's almost like it's religious, right? But I'm going to devote my time to a project, literally. And the beauty is that you can say, look, I'm not an accredited investor, and I'm in the U.S. Yet I know that project is a winner, right? And I'm specifically because of whatever class it's in, however they're doing, whatever they're doing to raise money. I can't put money in it, but I can signal to venture capitalists or other people who have the money and can put money into it. I can signal to them that project's amazing.
You're putting the equivalent of compute resources in on the Dragonchain, on DragonNet, and it makes it cheaper for that project, or more likely for it to survive.
Well, and beyond that, though, I can signal it, and the way devotion works, really interesting. There's an Ethereum smart contract where we calculate if you want to devote 1 million time to that project, you're actually burning it. The project doesn't get the time. The tokens, the certain amount of tokens required to devote 1 million time are sent to an Ethereum smart contract and back to you. And so basically all you're doing is moving enough dragons to lower the amount of time you have. And that is considered, it's a very scarce resource, so the application of it to that project warrants that you get coupons that are related in certain ways, so that when the project actually goes live, you can come in and do things on it. So a whole bunch of really neat stuff, but and we've gone through a tremendous amount of legal checks and trying to find the right partner, and so we have somebody that's going to pick that up and can use it in very neat ways, especially with very traditional systems. So it'll be good.
Cool.
So I think it's everything for time, right?
It is, and we'll go through some examples in future episodes of Super Happy as people start using it, and it'll be interesting for people to be able to see that. So
Right. Perfect.
all right.